Let me tell you about a planet that shouldn't exist. It's called WASP-12b, and it's being eaten alive by its own star. The gravity is so intense that this gas giant bigger than Jupiter is stretched into an egg shape. Its atmosphere is literally boiling off into space at 10 billion tons per second. 10 billion tons every second. And here's the kicker: scientists give it maybe 10 million years before it's completely devoured. In cosmic terms, that's like finding someone in the middle of being murdered and saying, they've got a few minutes left. But WASP-12b? That's not even the weirdest planet we've found. Not by a long shot. Since 1992, we've discovered over 5,000 planets orbiting other stars. And the universe, it turns out, has a twisted sense of humor. Because out there in the cosmic abyss, there are planets made of diamond worth more than the entire global economy. Planets where it rains molten glass sideways at 4,000 miles per hour. Planets darker than coal that absorb 99% of light. Rogue planets wandering through the void with no star at all, cosmic orphans drifting through eternal darkness. There are planets orbiting dead stars that should have been destroyed. Planets with 3 suns in the sky. Planets where a year lasts 4 hours. And planets where a year lasts 40,000 of hours. And every single one of these alien worlds tells us something terrifying and beautiful. Our solar system, our nice, orderly, predictable solar system, is the weird one. We're the cosmic anomaly. Welcome to the most bizarre exoplanets we've ever found. I'm about to take you on a 70-minute tour of the universe's most unhinged planetary experiments. Worlds so strange that when scientists first detected them, they thought their instruments were broken. Planets that rewrite the rules of physics and make our wildest science fiction look boring. Buckle up. It's about to get weird. Let's start with the planets that make hell look like a vacation resort. Because if there's one thing the universe excels at, it's creating environments that would kill you in progressively more creative ways. Meet the hot Jupiter's gas giants that orbit so close to their stars that their surfaces reach temperatures of 4,000 degrees Fahrenheit. That's hot enough to vaporize iron. These planets complete an entire orbit in just a few Earth days, sometimes hours. They're tidally locked, meaning one side always faces the star, creating a permanent day side that's essentially a blast furnace, and a night side that's only slightly less apocalyptic. But the king of the hell worlds? That's HD 189733b, and this planet is genuinely nightmare fuel. Picture this. It's a beautiful cobalt blue, like a gorgeous tropical ocean planet. Looks peaceful from a distance, right? Wrong. Dead wrong. That blue color doesn't come from water. It comes from silicate particles in the atmosphere. And those particles? They're being whipped around at 4,500 miles per hour. It rains glass sideways at speeds that would make a Category 5 hurricane look like a gentle breeze. The temperature is around 1,700 degrees Fahrenheit. The atmospheric pressure would crush you like a soda can. And just to add insult to injury, this planet is slowly being blasted apart by X-rays from its star. But hey, at least it's pretty, right? Now, HD 189733b is about 64 light-years away, which in cosmic terms is practically our backyard. Scientists have studied it extensively because it transits in front of its star from our perspective, meaning we can analyze its atmosphere when starlight passes through it. And that's how we know about the glass rain, by detecting the chemical signatures of vaporized silicates moving at insane speeds. Here's what would happen if you somehow survived the journey there and tried to land. First, you'd be obliterated by the radiation. But let's say you had a magic radiation shield. The moment you entered the atmosphere, you'd be sandblasted by microscopic glass particles moving faster than bullets. Your ship would be shredded. You'd be shredded. Everything would be shredded. And even if you had a magic glass-proof shield, the heat would vaporize you. and the pressure would compress what's left into a very small, very dead ball of organic matter. Space is not friendly. But HD 189,733b isn't even the hottest exoplanet we've found. That honor goes to KELT-9b. KELT-9b orbits a blue-white star in the constellation Cygnus, about 670 light-years from Earth. Its dayside temperature reaches 7,800 degrees Fahrenheit. That's hotter than most stars. Let me repeat that this planet is hotter than 70% of all stars in the galaxy. At these temperatures, molecules can't exist. The atmosphere is literally being torn apart into individual atoms. Hydrogen molecules split into hydrogen atoms. Even titanium and iron exist as gases. The planet is evaporating so fast that it leaves a comet-like tail of gas behind it. Scientists estimate KELT-9b loses about 10 to 100,000 tons of material per second. For context, that's roughly the weight of the Titanic evaporating into space every second. And the planet has been doing this for millions of years. Eventually, there won't be anything left. KELT-9b is committing very slow, very hot suicide. Now you might be wondering, how did these planets end up in such terrible locations? Great question. The answer involves a process called planetary migration, and it's equal parts fascinating and horrifying. When solar systems form, gas giants typically form farther out, where it's cold enough for ice and gas to accumulate. Jupiter, Saturn, Uranus, Neptune, they all formed beyond what we call the frost line, the distance from the sun where water can freeze. But hot Jupiters are orbiting closer to their stars than Mercury orbits our sun. So, how did they get there? They migrated. Through interactions with the protoplanetary disk, the disk of gas and dust from which planets formed, these gas giants slowly spiraled inward. Some were pushed by gravitational interactions with other planets. Some were pulled by the disk itself. And once they got close to their stars, tidal forces locked them in place. And here's the nightmare scenario. This probably happens during the early, chaotic phase of solar system formation, which means that any rocky planets that were in the way, Earth-like, worlds forming in the habitable zone, got swallowed or ejected into interstellar space. Hot Jupiters are planet killers. They probably destroyed countless worlds on their way inward. But let's talk about the absolute weirdest of the hell worlds, the Levy planets. Corot 7b was one of the first rocky exoplanets ever discovered, found in 2009. It is about 70% larger than Earth and orbits its star so closely that its year lasts just 20 hours. 20 hours. The dayside temperature is about 4,000 degrees Fahrenheit, hot enough to vaporize rock. Scientists believe the surface is an ocean of molten lava, constantly churning and bubbling. The planet probably has an atmosphere, but it's made of vaporized rock, literally a rock vapor atmosphere. Think about that. Rock, vapor. As in, the ground is so hot it turns into gas and forms an atmosphere. And when that rock vapor rises high enough in the atmosphere, it cools down and condenses. It rains rocks. Pebbles and stones precipitating out of the sky like raindrops. Though rain implies they gently fall, and at those temperatures with that atmospheric pressure, they probably slam down like meteors. But Corot 7b has competition in the most hellish surface category. Enter 55 Cancri e. This planet is nicknamed the Diamond Planet, and we'll get to why in a bit. But first, let's talk about its surface conditions, which are, surprise, completely awful. 55 Cancri orbits its star in just 18 hours. Its surface temperature fluctuates between 2,000 and 4,900 degrees Fahrenheit, depending on which side is facing the star. It's tidally locked, so one side is always roasting, while the other side is merely hellish. The planet is superdense, twice Earth's diameter, but 8 times the mass. Gravity is about twice Earth's gravity. And scientists believe the surface might be covered in flowing lava, with a thin atmosphere of vaporized rock, similar to Corot 7b. But here's where 55 Cancri e gets interesting. Because of its extreme density and the chemical composition suggested by its mass, some scientists theorize that beneath the lava crust, the planet might have a mantle made of diamond. We're talking about a planet where the bedrock is literally crystallized carbon. A world where diamonds aren't precious gems, they're just rocks, the stuff mountains are made of. Now, before you start planning a mining expedition, let me crush your dreams with some math. 55 Cancri e is 40 light-years away. With our current fastest spacecraft, that would take about 700,000 years to reach. And even if you got there, you'd have to somehow mine through a lava crust under twice Earth's gravity in 4,000-degree temperatures. But sure, let's start a Kickstarter. The hell worlds teach us something important. Planets can exist in conditions we thought were impossible. For decades, astronomers assumed gas giants could only form far from their stars. Hot Jupiters proved that wrong. We thought rocky planets couldn't survive that close to stars. Lava planets proved that wrong too. And the disturbing implication is this. These aren't rare flukes. Hot Jupiters and lava planets are everywhere. We've found hundreds of them. Which means that planetary formation is way more chaotic, way more violent, and way more flexible than we ever imagined. The universe doesn't follow rules. It makes them up as it goes. All right, we've covered the planets that will burn you alive. Now let's talk about the planets that will freeze you solid. Because balance, apparently, is not the universe's strong suit. The gas giants in our solar system, Jupiter, Saturn, Uranus, Neptune, are cold. Neptune's average temperature is minus 353 degrees Fahrenheit. That's cold enough to freeze methane, which is why Neptune has methane ice clouds. But out there in the galaxy, there are ice giants that make Neptune look tropical. Meet OGL E2-005BLG39OLB. Yes, that's its actual name. Astronomers are terrible at naming things. It's 21,500 light-years away, which makes it one of the most distant exoplanets we've ever detected. And it's cold, minus 364 degrees Fahrenheit cold. This planet is about 5.5 times Earth's mass, a category we call super-Earth, which is misleading because there's nothing super about this frozen hellscape. It orbits a red dwarf star at a distance similar to how far Jupiter orbits our sun. But red dwarfs are dim, so the planet receives almost no heat. The surface is probably covered in frozen methane, nitrogen, and carbon monoxide ice. If there's an atmosphere, it's been frozen solid onto the surface. This is a world where the air itself has turned to snow and fallen solid chunks. Space, I'm noticing, is just consistently terrible in every possible way. But OGL E2005BLG39OLB was discovered using a fascinating technique called gravitational microlensing. Here is how it works. When a star passes in front of a more distant star from our perspective, the foreground star's gravity bends and magnifies the light from the background star. It's like the star is acting as a cosmic magnifying glass. If the foreground star has a planet, the planet's gravity causes a tiny additional blip in the light curve, a brief brightening that lasts hours or days. By analyzing that blip, astronomers can calculate the planet's mass and distance from its star. The crazy part? This blip only happens once. You get one shot to detect it. If you blink, you miss it. OGL E2005BLG39OLB's microlensing event lasted a few days in 2005, and then it was gone. We'll never see it again. So somewhere out there, 21,500 light-years away, there's a frozen ball of ice orbiting a dim red star, and we detected it for a brief moment, and now we'll never be able to study it further. Space is full of one-night stands. But cold planets orbiting distant stars are at least still attached to their stars. There is a whole category of planets that said, screw this, and cut all ties with stellar gravity. They're wandering through the galaxy alone, frozen and dark, and utterly isolated. Ladies and gentlemen, meet the rogue planets. These are worlds that either formed without a star, or more likely, were ejected from their solar systems during the chaotic early days of planetary formation. Maybe a close encounter with a gas giant flung them into interstellar space. Maybe their star went supernova, and the explosion kicked them out. Either way, they're adrift in the void with no sun, no light, no heat. And here's the terrifying part. There might be billions of them in our galaxy alone. Possibly more rogue planets than stars. Think about that. For every star you see in the night sky, there could be dozens of invisible planets drifting through the darkness, completely undetectable unless they happen to pass in front of a background star or stumble through our solar system. Oh, didn't I mention? A rogue planet could enter our solar system at any time, and we probably wouldn't see it coming until it was already here. Now, before you panic, the odds of a rogue planet hitting Earth are astronomically low. Space is really, really big, and rogue planets are really, really small compared to the distances involved. But gravitationally disrupting the orbits of outer planets, sending comets from the Oort cloud spiraling toward the inner solar system, that's within the realm of possibility. In 2021, astronomers using the optical gravitational lensing experiment, OGLE, that project again, estimated there could be at least 2.5 rogue planets per star in the Milky Way. With 100 to 400 billion stars in our galaxy, we're talking about anywhere from 250 billion to 1 trillion rogue planets. 1 trillion planets. Just wandering around, lost, orphaned, forever. The universe is a sad place when you really think about it. But some rogue planets might not be completely frozen. And this is where it gets weirdly interesting. If a rogue planet is large enough, say, several times Jupiter's mass, it can generate internal heat from its formation, from radioactive decay in its core, and from gravitational contraction. This heat could theoretically keep a subsurface ocean liquid even without a star. Imagine a Jupiter-sized world drifting through interstellar space with a thick hydrogen atmosphere trapping heat, and beneath its frozen surface, an ocean of liquid water warmed by the planet's own internal heat. And in that ocean, maybe life. I'm not saying it's likely, but it's not impossible. Life on Earth exists in conditions we thought were impossible, in boiling hydrothermal vents, in frozen Antarctic lakes, miles underground in solid rock. If life can exist there, maybe it can exist in the dark ocean of a rogue planet, drifting forever through the cosmic void, unaware that stars even exist. That's simultaneously beautiful and deeply, deeply unsettling. Now, let's just talk about another frozen oddity, the planets that orbit so far from their stars that they barely even in the same solar system. HD 106906b is a gas giant 11 times more massive than Jupiter, and it orbits its star at a distance of 738 astronomical units. 1O is the distance from Earth to the Sun, so this planet is 738 times farther from its star than we are from ours. To put that in perspective, Neptune, our most distant major planet, orbits at 30 astronomical units. Pluto's orbit averages about 40 astronomical units. HD 106906b is almost 20 times farther out than Pluto. At that distance, the star is just a bright point of light. This planet receives almost no warmth. Its year one complete orbit takes 15,000 Earth years. 15,000 years. The planet's existence is a mystery. It's too far out to have formed through normal planetary accretion. The protoplanetary disk shouldn't extend that far. One theory is that it formed much closer to the star and was kicked out by gravitational interactions with other planets. Another theory is that it formed like a binary star system, two objects forming together from the same cloud of gas. But here is the weirdest part. HD 106906b's orbit is highly elliptical and tilted compared to the rest of the system. Something kicked it into this bizarre orbit, and whatever did that might still be out there. Somewhere in that system, there might be a planet we have undetected yet, a gravitational puppet master that threw this gas giant into its weird orbit. The frozen worlds and rogue planets remind us that planetary systems are violent, chaotic places. During their first 100 million years, solar systems are demolition derbies. Planets migrate, planets collide, planets get ejected. The survivors are the lucky ones. Our solar system probably ejected several planets during its formation. There might be Earth-sized worlds that formed near where we are now, only to get kicked out by Jupiter's gravity. They're out there somewhere, frozen and dark, drifting through interstellar space. Lost siblings of Earth, wandering the galaxy forever. But not all weird planets are defined by temperature. Some are weird because of what they're made of. And that's where things get really interesting and really expensive. Pop quiz. What's the most valuable substance in the universe? Gold? Platinum? Antimatter? Bitcoin? How about diamond? Specifically, an entire planet made of diamond. We already met 55 Cancri E, the lava world with a hellish surface. But beneath that lava, scientists believe there's a mantle composed primarily of diamond, not diamond deposits or diamond veins. The entire mantle is one massive diamond crystal. The planet's mass and density suggest it's carbon-rich. Under the extreme pressures and temperatures beneath the surface, that carbon would crystallize into diamond. We're talking about a diamond the size of a planet. The estimated value? If you could somehow harvest and sell it accounting for the fact that flooding, the market would crash diamond prices, we were looking at roughly $26.9 million. That's 26.9 with 30 zeros after it. For context, the entire global economy is worth about $100 trillion. With a T55 Cancri is worth more than 250 billion times the entire economic output of humanity. But yeah, tell me again how diamonds are rare and valuable. The existence of diamond planets tells us something important about planetary formation. Composition matters as much as size. In our solar system, planets are broadly divided into rocky Mercury, Venus, Earth, Mars, and gaseous, Jupiter, Saturn, Uranus, Neptune. But that's not the only recipe. Some planets are carbon-rich instead of oxygen-rich. Some have exotic ices. Some have atmospheres made of metals. The universe is experimenting with every possible combination of elements under every possible condition. And some of those combinations create planets that are worth more than entire civilizations. Take WASP-18b. This hot Jupiter completes an orbit every 23 hours, and its atmosphere contains gaseous iron and titanium. When scientists analyzed its spectrum, they found carbon monoxide, which makes sense, but almost no water vapor. Almost no water. On a gas giant. This shouldn't be possible. Oxygen is one of the most abundant elements in the universe. Gas giants should have loads of oxygen bound up in water molecules. But WASP-18b is so hot that water molecules break apart, and the oxygen is likely bound up in other compounds. So we've got a planet with an atmosphere of vaporized metal and almost no water. Add it to the list of things that shouldn't exist, but do anyway. But let's talk about the weirdest treasure world, Kepler 7b. Kepler 7b is a hot Jupiter with an atmosphere full of clouds. But these aren't water clouds or ammonia clouds. Scientists detected silicate vapor clouds made of vaporized rock and minerals. The planet is so hot that rock evaporates, rises into the atmosphere, condenses into tiny droplets, and forms clouds. Rock clouds, just rolling off the tongue there. But wait, there's more. The clouds on Kepler 7b are concentrated on the western side of the planet. You know how on Earth, weather patterns are driven by the planet's rotation and temperature differences? Same thing here, except the weather is vaporized rock being blown around at thousands of miles per hour. If you were somehow hovering in the atmosphere of Kepler 7b, you'd be inside a cloud of liquid rock droplets. It's raining molten pebbles. The sky is literally falling. And these worlds 55 Cancri e, WA, SP18b, Kepler 7b, they're teaching us that planets can be made of almost anything. Carbon planets, iron planets, water planets with oceans hundreds of miles deep, planets with diamond cores and ruby clouds and gold rain. The universe is basically a cosmic mineral collection with delusions of grandeur. But some planets aren't just weird because of what they're made of. They're weird because they shouldn't exist at all. Enter WD-1856b. This planet is a Jupiter-sized gas giant orbiting a white dwarf star every 34 hours. And the scientific community's reaction when this was discovered in 2020 was essentially, how? How is this possible? Here's the problem. White dwarfs are the corpses of sun-like stars. When a star like our sun runs out of fuel, it swells up into a red giant, engulfing the inner planets, before finally shedding its outer layers and collapsing into a white dwarf. Our sun will become a red giant in about 5 billion years. It will expand past Earth's orbit. Earth will be vaporized. Mercury and Venus will definitely be consumed. Maybe Mars too. Sleep tight. So how is WD-1856b still there? This planet orbits closer to its white dwarf than Mercury orbits the Sun. It should have been swallowed when the star was a red giant. It should have burned up. It should be gone. But it's not. It's right there, orbiting every 34 hours like nothing happened. The leading theory is that WD-1856b originally orbited much farther out, maybe where Jupiter-like planets normally form, and then migrated inward after the star became a white dwarf. Maybe gravitational interactions with other planets pushed it inward. Maybe the mass loss when the star shed its outer layers caused orbital reshuffling. But honestly, we don't know. This planet shouldn't exist, but here it is. A cosmic middle finger to everything we thought we understood about stellar evolution. And WD-1856b isn't alone. We found other planets orbiting white dwarfs, and each one is a puzzle. These are survivors' planets that somehow made it through the apocalypse of their star's death. Which raises an interesting question. When our sun dies and becomes a white dwarf 5 billion years from now, will any of our planets survive? Jupiter and Saturn are probably safe, they're far enough out. But will they stay in their current orbits? Or will they migrate inward? And if they migrate inward, they'll pass through the zone where Earth used to be. They'll be orbiting through the ashes of our world. That's a cheerful thought. But let us talk about another category of planets that shouldn't exist. The ultra-hot Jupiters that are somehow still holding together. Remember KELT9b? The hottest planet we've ever found? Yeah, it's not just hot, it's disintegrating. The stellar radiation is so intense that it's ripping hydrogen molecules apart into individual atoms. The planet has a comet-like tail of escaping gas. By all rights, this planet should have evaporated by now. But it's still there, still orbiting, still losing atmosphere at 1,000 tons per second. It's like watching someone bleed out in slow motion over millions of years. Uncomfortable, but scientifically fascinating. The question is, how long has this been going on? And how much atmosphere has it lost? Was KELT9b once much larger, and we're just seeing what's left after billions of years of evaporation? Some models suggest that many hot Jupiters start out as even larger planets and shrink over time. What we re-seeing today might be the remnants of super-Jupiters that were twice or 3 times Jupiter Cis, which means that planetary atmospheres are temporary. Given enough time and the right conditions, any atmosphere can be stripped away. Even Jupiter, if you moved it close enough to the Sun, would eventually lose its atmosphere and become a rocky core. Nothing lasts forever, not even planets. The treasure worlds and impossible planets teach us something profound. Our assumptions about what planets can be and where they can exist are constantly being overturned. We thought gas giants had to be cold. Wrong. We thought diamond planets were science fiction. Wrong. We thought planets couldn't survive their star's death. Wrong. Every time we point our telescopes at a new star system, we find something that makes us go, wait, that's not supposed to be possible. And I love that. Because it means the universe is weirder than we can imagine. And that's exciting. Remember Star Wars? Tatooine, with its iconic double sunset, two suns dipping below the horizon? Yeah, George Lucas wasn't just making stuff up. Circumbinary planets that orbit two stars, are real. And they're weirder than anything in the movies. The first confirmed circumbinary planet was Kepler 1.6b, discovered in 2011. It orbits two stars, one orange dwarf and one red dwarf, that orbit each other every 41 days. The planet itself orbits both stars every 229 days. Now, you might think, okay, that's cool, but not that weird. Oh, but it is. Because the gravitational dynamics of a three-body system are chaotic. Predicting long-term stability is incredibly difficult. These planets shouldn't be stable, yet they are. Here's the challenge. In a single star system, a planet's orbit is relatively simple. It's an ellipse, and the math has been solved since Newton. But add a second star, and suddenly you have three massive objects all gravitationally influencing each other. The planet's orbit becomes a complex dance, shifting and wobbling in ways that are difficult to predict. And yet, Kepler 1.6b has probably been orbiting its binary stars for billions of years without getting flung into interstellar space or crashing into one of its suns. The universe is better at orbital mechanics than we are, which is either humbling or annoying, depending on your perspective. But circumbinary planets aren't the weirdest multiple star scenario. Oh no. Let me introduce you to HD 131399 AB. This is a gas giant that orbits in a system with three stars. 3. The planet orbits one star, while the other two stars orbit each other, and the whole group orbits around a common center of gravity. Just trying to visualize that makes my brain hurt. From the surface of HD 131399A, if it had a surface, which it doesn't because it's a gas giant, you would see three suns in the sky. Depending on where the planet is in its orbit, you might have triple sunrises, sunsets with overlapping shadows, or periods where one sun sets just as another rises. The planet's orbit is highly eccentric and unstable. In fact, some scientists debate whether it is even gravitationally bound to the system, or if it is in the process of being ejected. This might be a planet in the middle of getting kicked out into interstellar space, and we're just happening to catch it during its final laps around its star. Talk about bad timing. But triple star systems are actually more common than you'd think. About 10% of star systems in our galaxy are trinary systems or higher, which means there could be millions of planets out there with multiple suns, experiencing day-night cycles and seasons that would be completely alien to us. Imagine growing up on a planet where sometimes the sun sets and another sun immediately rises. Or where you have 3 different winters, depending on which sun your hemisphere is tilted away from. Or where solar eclipses happen weekly, because your suns keep passing in front of each other. Your calendar would be a nightmare. Your circadian rhythms would be all over the place. Evolution would have shaped life, if there is life, in completely unexpected ways. But let's talk about orbital chaos in single-star systems, because it turns out you don't need multiple stars to create gravitational mayhem. Enter TRAPPIST-1. This is an ultra-cool red dwarf star about the size of Jupiter, but much denser, orbited by 7 Earth-sized planets. 7. All of them rocky, 3 of them in the habitable zone. And they're all crammed into a space smaller than Mercury's orbit around our sun. It is like someone took our entire inner solar system and compressed it into a space the size of a living room. The planets orbit their star in periods ranging from 1.5 days to 18.8 days. They're so close together that if you stood on the surface of one planet, the neighboring planets would appear larger in the sky than our moon. During transits, you could watch other planets pass in front of the sun with your naked eye. But here's the fascinating part. The 7 planets are in orbital resonance. This means their orbital periods are related by simple ratios. For every 2 orbits of one planet, the next one completes 3 orbits, or 4, or 5. It's like a cosmic musical chord, all the planets harmonically locked together. This resonance keeps the system stable. Without it, the planets would gravitationally perturb each other, and the system would eventually fall apart. But because they're in resonance, they're locked in a delicate gravitational balance that could potentially last for billions of years. It's like watching 7 tightrope walkers, all holding on to each other, all walking in perfect synchronization. One misstep and everyone falls, but they've been doing this for billions of years without fail. The TRAPPIST-1 system teaches us that planets can pack together much more tightly than we thought possible. Our solar system has huge gaps between planets. Venus to Earth is 26 million miles. Earth to Mars is 140 million miles. But TRAPPIST-1's planets are separated by distances of just a few million miles. And this isn't unique. We've found dozens of compact multi-planet systems. Kepler 11 has 6 planets packed inside an orbit smaller than Venus's. Kepler 90 has 8 planets, as many as our solar system, but all of them orbit closer than Earth does to the Sun. Apparently, nature really likes efficiency. But tight orbits create weird possibilities. If 2 planets pass close enough to each other, their atmospheres could temporarily connect. Gas from one planet could flow to the other during close approaches. And if one of those planets had life? Well, now you've got interplanetary panspermia life spreading from one planet to another through atmospheric exchange. Bacteria, spores, microorganisms hitching a ride on atmospheric transfer. In tightly packed systems like TRAPPIST-1, life might not evolve independently on each planet. It might spread across all of them. You could have a system where all 7 planets share a biosphere, one interconnected network of life spanning multiple worlds. That's either really cool or the setup for a cosmic horror story. Possibly both. Now let's talk about the most chaotic orbits in existence. Planets that orbit their stars backwards. Most planets orbit in the same direction their star rotates. This makes sense. They all formed from the same rotating disk of gas and dust, so they inherited that rotation. Earth, Mars, Jupiter, we all orbit the Sun in the direction the Sun rotates. But some exoplanets orbit in the opposite direction. They're moving backwards, counter to their star's rotation. These are called retrograde orbits, and they indicate something catastrophic happened in that system's past. HAT P7b is a hot Jupiter with a retrograde orbit tilted about 182 degrees relative to its star S equator. It's literally going the wrong way. The most likely explanation: gravitational interactions with another massive planet or a passing star kicked it into this weird orbit. Maybe it was originally orbiting normally, then got perturbed, and through a complex series of gravitational slingshots, ended up going backwards. Imagine being that planet. You're just minding your own business, orbiting normally, then some massive gravitational bully comes along and flips you around. Now you're going backwards for the rest of your life, wondering what you did to deserve this. But retrograde planets prove that solar systems aren't static. They're dynamic, violent environments where gravitational interactions can completely reshape orbits. Planets that start in one configuration can end up in completely different orbits millions of years later. And this has implications for our solar system. Jupiter probably migrated inward and then back outward during the early days of the solar system. This migration might have scattered asteroids and comets, caused bombardments of the inner planets, and reshaped the entire architecture of our planetary neighborhood. We like to think of our solar system as stable and orderly, but it's the survivor of billions of years of chaos. We're living in the aftermath of cosmic demolition derby. The multi-star systems and chaotic orbits remind us that gravity is both elegant and brutal. It creates beautiful orbital resonances and stable systems, but it also flings planets into interstellar space, crashes moons into planets, and occasionally just flips an entire planet's orbit backwards for no good reason. Gravity, the universe's way of reminding us that nothing is permanent. All right, we've spent an hour talking about hell worlds, frozen wastelands, diamond planets, and orbital chaos. Now let's talk about the planets that might be capable of supporting life. And before you get excited, let me be clear. Potentially habitable doesn't mean definitely has life or even nice place to live. It means liquid water could theoretically exist on the surface. That's the bar. And by that standard, there are some bizarre candidates. Let's start with Proxima Centauri b, our closest exoplanetary neighbor at just 4.2 light-years away. It's roughly Earth-sized, orbits in the habitable zone of its star, and might have liquid water. Sounds great, right? Wrong. Proxima Centauri is a red dwarf star cool, dim, and cranky. Red dwarfs are known for stellar flares, violent eruptions of radiation that can strip away a planet's atmosphere. Proxima Centauri is particularly bad, with massive flares happening regularly. Proxima b orbits its star every 11 days. It's tidally locked, meaning one side always faces the star permanent day on one hemisphere, permanent night on the other. The day side gets roasted by stellar flares. The night side is frozen. The only habitable zone would be a narrow ring around the terminator, the boundary between day and night. And even if liquid water exists, the radiation environment is brutal. Any life would need to be underground or underwater to survive the flares. So yeah, potentially habitable is doing a lot of heavy lifting in that description. But Proxima b is interesting for another reason. It's close enough that we might actually be able to study it in detail. With next-generation telescopes, we could potentially analyze its atmosphere, look for biosignatures, maybe even detect oxygen or methane gases that could indicate life. And if we ever develop interstellar travel big, if Proxima b would be the first target. A journey to Proxima Centauri at 10% the speed of light would take about 42 years. Long, but theoretically possible with technology we can imagine. Of course, you'd arrive at a tidally locked hell world being periodically sterilized by stellar radiation. But hey, at least it's close. Now let's talk about the ocean world's planets that might be entirely covered in water. GJ1214b is a mini Neptune about 48 light-years away. It's about 2.7 times Earth's diameter and 7 times Earth's mass. And it's weird. The planet's density suggests it's not rocky like Earth, and it's not a gas giant like Neptune. The best model is that it's a water world, a planet with an enormous, deep ocean covering its entire surface. But we're not talking about Earth-like oceans. We're talking about oceans hundreds of miles deep, with pressures so intense that water transitions into exotic forms. At the bottom of these oceans, water would be compressed into hot ice, solid water that exists at temperatures of hundreds of degrees because of the pressure. Ice. That's hot. Just let that sink in. Deeper still, you'd find superionic ice, a bizarre state of matter where oxygen atoms are locked in a crystal lattice, but hydrogen atoms flow freely like a liquid. It conducts electricity like a metal, but it's still ice. GJ1214b might have an ocean hundreds of miles deep, overlaying a layer of hot ice, overlaying a rocky core. There's probably no solid surface anywhere, just layers of increasingly weird water all the way down. Could life exist in these conditions? Maybe. Earth has life in the deepest ocean trenches, in pressurized environments we once thought were lifeless. If life can exist there, maybe it can exist in the crushing depths of a water world. But it would be nothing like life on Earth. No sunlight penetrates those depths. No land. No concept of surface or sky. Just an endless ocean in all directions forever. That's either peaceful or claustrophobic, and I'm not sure which. Now let us talk about the planet that broke everyone's brain when it was discovered. LHS 3844b. This is a rocky planet, about 1.3 times Earth's size, orbiting a cool red dwarf every 11 hours. And it has no atmosphere. None. Zero. How do we know? Because the temperature difference between the day side and night side is enormous. If there were an atmosphere, it would redistribute heat. But the day side is about 980 degrees Fahrenheit, and the night side is well below freezing. This is just a naked rock hurtling around a star. A planetary corpse stripped of its atmosphere, probably by stellar radiation over billions of years. And the surface? Scientists think it might be covered in volcanic rock basalt, like the lava plains on the moon. No water, no atmosphere, no weather. Just rock, heat, and radiation. It's the most boring exoplanet we've ever found in detail. And yet, it's as scientifically valuable because it gives us a window into what happens to close-in rocky planets around red dwarfs. This might be the fate of many potentially habitable planets, stripped atmospheres, dead surfaces, eternal silence. But let's end this section with the most baffling discovery of all, the planets around pulsars. PSR B1257 plus 12 is a pulsar, a rapidly spinning neutron star located about 2,300 light-years away. And it has at least 3 planets orbiting it. Let me repeat that. A neutron star has planets. Neutron stars are the collapsed cores of massive stars that exploded in supernova. They're the densest objects in the universe aside from black holes. A tablespoon of neutron star material would weigh 1 billion tons. They spin hundreds of times per second and emit beams of radiation like cosmic lighthouses. And somehow, impossibly, there are planets orbiting this cosmic horror. These planets shouldn't exist. The supernova that created the pulsar should have destroyed any planets that were there. These planets probably formed after the supernova from the debris disk of the explosion. Think about that. These are second-generation planets, born from the ashes of the star that destroyed the first planets. They're phoenixes rising from stellar destruction. And what are conditions like on these planets? Unimaginably hostile. The pulsar's radiation would sterilize the surface. The magnetic fields are intense enough to warp atomic structures. The gravitational tidal forces would be immense. If you stood on one of these planets, which you couldn't, because you'd be instantly killed by radiation, you'd see a neutron star spinning in the sky, flashing like a strobe light hundreds of times per second. The sky would be lit by X-rays and gamma rays. The ground would be bathed in deadly radiation. And yet, the planets exist. They orbit. They're stable. They've been there for millions or billions of years, circling their dead star in silence. These pulsar planets are a reminder that planets can exist in conditions we never imagined, around dead stars, in intense radiation fields, in gravitational environments that should tear them apart. The universe doesn't care about our categories or our assumptions. It creates planets wherever it wants, however it wants, under whatever conditions it feels like. So what do we take away from all this? What does it mean that the universe is full of diamond planets and lava worlds, and rogue planets and worlds orbiting dead stars? First, it means we were wrong about a lot of things. We thought gas giants only formed far from their stars. Wrong. We thought planets needed to orbit in the same direction as their star's rotation. Wrong. We thought planets couldn't survive supernova. Wrong. We thought you needed a sun-like star for habitable planets. Probably wrong. Every assumption we had about planetary formation has been challenged or overturned by observations. The universe is more creative, more flexible, and more chaotic than we ever imagined. Second, it means our solar system is weird, not special, not unique, just weird. We have 4 rocky planets nicely spaced in the inner system, 4 gas giants nicely spaced in the outer system, all orbiting in the same direction in roughly the same plane. It's orderly. It's stable. It's boring. Most planetary systems aren't like that. Most are chaos. Hot Jupiters orbiting where Mercury should be. Rocky planets stacked on top of each other. Retrograde orbits, missing planets. Exoplanets, orbital resonances, circumbinary madness. We're the exception, not the rule. Third, it means life, if it exists elsewhere, might be nothing like life on Earth. We're searching for planets in the habitable zone, with liquid water and Earth-like conditions. But what if life doesn't need Earth-like conditions? What if life can exist in the crushing depths of a water world? In the subsurface oceans of a rogue planet? In the weird chemistry of a carbon-rich world? We're looking for life like us, but the universe might have invented 1,000 other types of life that do and need what we need. And we'd never know, because we're not looking for them. Fourth, and most importantly, it means we need to keep looking. We've discovered over 5,000 exoplanets, and every single one has taught us something new. But there are estimated to be 100 billion planets in our galaxy alone. We've barely scratched the surface. The James Webb Space Telescope is analyzing exoplanet atmospheres. The next generation of ground-based telescopes, the extremely large telescopes, will be able to directly image planets. Future missions might find biosignatures, detect artificial lights, or discover forms of life we never imagined. We're living in the golden age of exoplanet discovery. Every week, new planets are being found. Every month, new papers are published revealing new weirdness. And I can't wait to see what we find next. So the next time you look up at the stars, remember, orbiting those distant points of light are worlds beyond imagination. Planets made of diamond, planets with 3 suns, planets wandering alone through the darkness, planets that rain glass and planets where the ground is lava, and planets that somehow survived the death of their stars. The universe is strange. The universe is beautiful. The universe is terrifying. And it's all out there, waiting for us to discover it. Thanks for watching. If you're as fascinated by these alien worlds as I am, subscribe, because we've only just begun exploring the cosmos. This is the universe we live in. Weird, wonderful, and absolutely full of surprises.